Yes, Nipun, can you hear me? Right. So today there was some error in joining that link. Okay. Before I start from my side, do you have any problem, any topic that you want to discuss? No? Okay. Wait. Uh, did you attend last time class? Yeah. Do you remember what we did? I think we discussed some multiple choice questions, right? Today I'm discussing a different set of questions today. Wait. Just sure, sure. You will get it. You will get it. No problem. No problem. You will get. Okay. Um. Wait. Let me open a file. Just a second. Last time you were not present, right? Nipun, you were not present here last time. Were you present last time? Okay. Mhm. So now I'm sharing my screen with you. I think only you are present today. Wait. Okay. Let us discuss some questions from the NCR, some multiple choice questions. Wherever you are stuck, let me know. I'll go into detail of the theory, right? Okay. The substance that is not a compound. Substance which is not a compound. Good. Graphite. What is salt here? What is the chemical formula salt? Do you know that? Yeah. Just a second. Right. Sodium chloride is the formula, right? And what about water? What is the chemical formula for the water? H2O. And what is sand chemically? Remember it. SiO2, silicon dioxide. So all these are compounds made up of two or different elements, but graphite is just a carbon, just one element. So this is not a compound. Okay, understood. Okay. The substance that decomposes upon heating. What is your idea now? Wait a minute. Yeah. Does oxygen will decompose? Does oxygen decompose? No. Phosphorus? No. Sulfur? No. Because pure element do not decompose. But I have a mercuric oxide HgO that will decompose to give Hg plus half of oxygen. So this will decompose. Understood? Right. Just a second. Let me see who has entered. Let me enter that boy. Hello. Yes. Is it Arav? Okay, Saksham. Okay. Right, Saksham. Okay. I think Nipun has gone back a bit. Hmm. I'm sharing my screen. Somebody has come. Wait. Nipun, are you there? Okay. Okay. Kalium is the name of potassium. Remember it. Kalium is the lattice name of potassium. You can note down. Okay. Can you name this one? Name the element used based upon the Uranus. And what is that symbol? Uranium. And what is the symbol? U. You can note down. If you don't know, okay. Okay. Now what is this? Combining capacity of elements. Combining capacity of elements. Valency. Good. Respiration is an example of chemical change or physical change. It's basically oxidation. Basically, it is a oxidation. Oxidation means addition of oxygen, right? So you can write it down these things. Respiration is an example of oxidation. Done. Dash smallest unit of matter. Atom. Yeah. What is photon? Photon carry dash charge. What is photon? Okay, proton. Proton. It is not a photon. It is a proton. What charge it carries? Positive charge, right? Okay. The particle of matter which take part in chemical reaction are called. No, I think that is called as a electron, right? Which take part in atom. Atom take part in chemical bonding, right? Atomicity of helium is 1. because the helium does not make any bond, right? So it exists as a monoatomic gas. So helium atomicity is equal to 1 only. Okay. Okay. Metal. Right. Non-metal have? Yeah, it can be negative. Mostly they have negative because they have tendency to gain electron. They have tendency to gain electron. Okay, now in a chemical reaction, dash are rearranged atoms. Yeah, wait, just a second. Hmm. Tick mark against the most suitable answer for alternative suggestion in the following. Okay, boiling point, melting point are what? Physical or chemical properties? Physical. Right? They are physical properties. A reaction of an element with other elements are, yes. To identify pure substance, property are compared with those of unknown substances. Physical or chemical? Uh, I think physical. Boiling point. For a pure substance, that is a particular fixed boiling point. Suppose I say I have water and water has a fixed boiling point, specific boiling point. But if you add some impurity to it, the boiling point will change. Boiling point will change. It means that is not a pure compound. Am I clear? Just a second. Somebody has come in. Let me. No, no one has come. Mhm. Can you see my screen? Okay. The most abundant element in the universe is good. At room temperature, the liquid non-metal is and liquid metal is. It means there are two ticks that you have to make. Bromine, non-metal is bromine, and okay, metal is okay. Understood? Yeah, mercury on the other side. Okay. Wait. I stopped sharing for some time. Wait a second. I'm sharing my screen with you, and today I'll be discussing about the gaseous state in detail, right? Can you see my screen? Yes, can you see my screen? Right. So you now tell me what do you mean by the word gas? How do you say that the particular subcompound is a gas? The gas particles are far apart from each other, right? Yeah. So the gas particles are far apart, number one, right? Molecules are far apart. Number two, they have very, very less intermolecular force of attraction, right? Very, very less intermolecular force of attraction. Number two, they have a high kinetic energy. They have high kinetic energy. Particles are in random motion. Particles are in random motion. What more we can add here? They have the property of fluidity. They flow from the region of the high pressure to the low pressure. From the region of the high pressure to low pressure. Am I clear? Right. So can you tell me what properties, what type of properties we can measure about the gases? What properties we can measure about gases? Yeah, what we can measure about the gas basically. Can we measure its mass? No. You can't measure the mass of a gas. We can't measure the gas pressure. We can measure. See how. First we take empty cylinder which does not contain any gas and measure its mass m. And then we add here gas. Means now this will have this m1 is the mass of the empty cylinder plus mass of the gas. Let it be it is equal to mass capital. So I can say capital M mass of the gas will be equal to capital M minus the mass of the empty cylinder. Yes or no? This way we can do. First we measure the mass, weight of empty cylinder and then fill it with the gas and find the total mass. So from total mass minus the mass of the empty cylinder will be equal to mass of the gas. Am I clear? Yes or no? Right. What more things we can measure about the gas? We can measure its volume. Actually, the gas occupies the whole volume of the cylinder. Whatever the amount of the gas is, it will occupy the whole volume. It means volume of the gas is equal to volume of the cylinder in which it is placed. Suppose I say I have a 10 grams of the carbon dioxide. It will occupy how much volume? That will occupy volume of the complete cylinder, whole volume of cylinder. And cylinder may be of any volume. It may be just 1 liter, it may be of the 2 liter, it may be of the 3 liter, it may be of the 10 liter, whatever, it will occupy the whole volume. Yes or no? Because the gas particles are equally homogeneously distributed throughout the volume. Getting me? Right. What about what more thing we can measure about the gas? What more things we can measure about the gas? We can measure its pressure, right? Can you tell me how do you define pressure? How do you define pressure? Okay, force exerted by the gas per unit area. So force per unit area is called as a pressure. To measure the pressure, what do you how do you measure it? Do you know how do we measure the pressure? How do you measure the pressure? Pardon? How do we measure the pressure of a gas? How do we measure the pressure of a gas? Suppose the pressure is inside your cylinder. Can we determine its pressure? Or the gas air is in the tire of your vehicle. Can you measure the pressure? Have you seen at the fuel station? They check the air pressure. Yeah. So, do you, which instrument do they use? Which instrument do they use? Yeah. Do you know? Yeah, yeah. Barometer or they use a manometer. Okay. Before I go ahead, you know this? What is matter? Right. Anything that occupies space and has mass is called as a matter. It can be in any of the three physical states. It can be solid, it can be liquid, it can be gas, right? It can be. So, what are common forms of matter? Can you tell me? Solid, liquid, gas. Yeah. It can be solid, it can be liquid, it can be gas, right? Okay. If you see the difference between the two, definite shape is there in the solid. Do the liquid have definite shape? Do liquid have definite shape? No. Do gases have definite shape? Do gases have definite shape? Or they occupy the volume of the container? They don't have definite shape. Specific volume. Solids have definite specific volume. Yes. What about liquid? No. Yeah, yeah, a definite volume. And what about gas? No. You can note down if you feel like. If you can don't note down. Done. Okay. Intermolecular force of attraction. Intermolecular force of attraction. Means between two molecules, what type of forces are there? In case of solid, they are strong, a weak in liquid, and very weak in case of the gases. Now, packing. Very close packing is solid, loose in case of liquid, and very, very loose in case of the gas. Right? Like this, in this particular volume, so many particles are there. In the same volume, less number of particles are there. Right? Solid, liquid, and the gas. Are these interconvertible? Yes or no? Are these interconvertible? Can we convert from solid to the gas or gas to liquid or something? Yeah. So we can convert, right? By how we can convert ice into water? By rising temperature or decreasing temperature? Yes or no? So in case solid, the particles are closely packed. In case of liquid, they are loosely held. In the gas, particles are very loosely held. Okay. So interparticular force of attraction is very strong in case of the solid, less in case of the liquid, very less in case of gases. Understood? What about density? Which has the highest density? Which- Yeah, high, less than solid, and gases are the least. Right? Understood? Put it down. Do you know how many other forms of matter exist apart from solid, liquid, gas? They are there, right? Now, plasma state, both Einstein condensate, fermionic condensate, quark condensate, colloidal state. These are more forms of colloidal states. Matter might exist in these states also. Note it down. Note it down. We can discuss a little bit about it. Yeah, these are also states of matter. Apart from solid, liquid, gas, these are also states of matter. Pardon? Three are these. Three are solid, liquid, gas, and five are these. Total equal to eight. Okay. Work upon this question. Yeah. Solid has what? Yeah. Fixed volume and fixed mass. Hmm. Uh, inter at molecular force reduction when the gas molecule is weak, very weak here. Okay. Can you tell me what are the conditions that defines whether the substance will solid, liquid, or gas? What are the conditions which makes it which makes something no means what decides whether the substance will be solid, liquid, or gas? No, there are two things are there. Number one is the temperature, and second the pressure. And if you see, if you rise the temperature, the solid will be converted to liquid. If you further raise the temperature, liquid will be converted into gas. Yes or no? So temperature decides here. Number one factor is the temperature. Okay. Now, so it means what happens with that? With rise in temperature, the kinetic energy of the molecules increases. Kinetic energy. What is kinetic energy? Yeah, with half mv square. Technically, half mv square. You might have done in the physics also. Kinetic energy is equal to half into mass into velocity square. It is the energy due to the motion. Understood? So second factor is the pressure. Here I have gases. Now if I increase the pressure, the particles will come down closer, and what will happen? The particle will develop some attractive forces, and with that it will turn to liquid. It means the gases can be converted into liquid by decreasing temperature and by increasing pressure. So liquid to gas requires what? We need low high temperature, right? And pressure should be low. I want to convert liquid into gas. Then I need to increase the temperature and I had to decrease the volume. Pressure. Okay. So let us see this experiment here. Here I have gas, and if I raise the temperature, what will happen? The gas will occupy more volume and the piston will move up. Yes or no? So transfer gas into liquid. Can you suggest me what are the conditions I should do so that I can convert gas into liquid? I'll require low temperature and high pressure. Yeah. Done. Should we go ahead? Okay. No. No. Answer this question. Good. Answer this question. Yeah. Gas liquid into gas. I need high temperature. Right. Right. It was just introduction of this chapter. And now let us go to the next topic now. What are the properties I told you that we can measure? Yeah, we can measure the volume, we can measure the pressure, mass, pressure, temperature, density, and diffusion. All these properties can be can be determined. Note down what properties we can measure. Just a second. Yeah, have you noted down? Yes, done. Yes or no? Right. Now, mass W1. I filled the mass with the gas, right? And this mass is measured, right? I told you that how to measure the mass. I'll measure the weight W2 minus W1 is the mass of the gas. Empty cylinder plus mass of the gas is equal to total mass. If I subtract the mass of the empty cylinder, that will be the mass of the gas, right? And this mass, the amount of the gas is always measured in terms of moles. It expresses the amount of the gaseous substances. Note down. Moles express the amount of the substance. It can be in any form, maybe solid, maybe liquid, maybe gas. Now, what is mole? Yeah. So it's just like this: 1 dozen is equal to 12, 1 mole is equal to this much unit, right? If I say 1 mole of electrons, that will be equal to this much number of electrons. If I say 1 mole of molecules, that will be equal to the 6.02 to 10 to the power 23 number of molecules. Yeah. Okay, what is the meaning of 1 mole of sodium chloride? It means 1 mole of such type of units will be there, right? So how do you read this equation? I can read it like this: 1 mole of hydrochloric acid react with the 1 mole of NaOH and it produces 1 mole of sodium chloride and 1 mole of water. 1 mole of HCl means equal to the molecular weight. Have I taught you this thing? So this way I can say 1 mole is equal to Avogadro number of molecules of I say hydrogen, that will be equal to molecular weight. Yeah, right. Okay. So volume means volume amount of space occupied. More volume, SI unit is equal to meter cube. And 1 meter cube, you can note down. Yeah. So 1 dm cube is equal to 10 to the power 3 cubic centimeter. And 1 dm is equal to 10 dm. So you can convert one unit into the another unit. So we can convert one unit into the another unit, right? Put it down. Hello. Done. Right. So similar pressure. Pressure is the force exerting per unit area. To measure the pressure, what I do is I take up this instrument known as the barometer to measure the pressure. Not getting me? See, what is the manometer? What is the barometer? It's just a beaker that is filled with the mercury, and here I have a long tube. Air exert pressure here, and the mercury level rises up. It is going up to the 760 millimeters, and that shows that it is 1 atmospheric pressure. Okay, 760 millimeter of mercury or 76 centimeter of mercury. Noted down. Now, pressure is equal to 1 atmosphere, and that is equal to 1 bar. Force per unit area, Newton per meter square is the unit. Write down, pressure unit is Newton per meter square. Newton per meter square. Okay, so pressure is equal to 1 atmosphere is equal to this much pascals, 1.01325 10 to the power 5 pascal is equal to 1 atmosphere. Getting me, section? Right. And this is equal to, if I divide by 1000, it will be kilopascal or kilonewton per meter square. .76 centimeter of mercury. 1 atmosphere is equal to 76 centimeter of mercury or 760 millimeter of mercury. Basically, 1 atmosphere is equal to all these in different units. Understood? It is equal to 760 torr. 1 mm of mercury is equal to 1 torr. So we can convert one unit into the another unit. These are the different units of pressure. Hopefully it's all clear, right? Now temperature. What is temperature? Degree of hotness or coldness. Degree of hotness or coldness of a liquid is called as a degree of hotness is called as temperature. SI unit is degree Celsius or Kelvin scale. So one thing you have to keep in mind that we can convert one unit to another unit. Temperature the Kelvin scale is equal to temperature degree Celsius plus 273. So we can convert one unit into the another unit. Okay. So temperature Kelvin scale is equal to temperature degree Celsius plus 273. We can convert degree Fahrenheit also into degree Celsius. So degree Celsius is equal to 5 by 9 degree Fahrenheit minus 32. Okay. So degree Fahrenheit is equal to 9 by 5 degree Celsius plus 70 plus 32. We can do it like this also. So we can convert one unit into the another unit. Pardon? Temperature in degree Celsius that you can put here and we can convert to the degree Fahrenheit. Suppose I say that your body temperature, right? When you go to doctor and check your blood, but check your body temperature, they measure it in degree Fahrenheit, and they say that your fever and your temperature is 100 degree Fahrenheit. Then what is the temperature in the degree Celsius? You can convert. So 100 is equal to convert to degree Celsius. You can apply this formula now. 5 by 9, 100 minus 32. So 5 by 9, 32 minus करेंगे that will be equal to now 68. Yeah, 35 degrees. Yeah, somewhere. Right? We can convert. Understood? We can convert. Okay. Density is equal to mass per unit volume. Kg per cubic meter. So the SI unit will be equal to kg per cubic meter. That is the density. Okay. Done. So what is diffusion? Diffusion means free intermixing of two or more gases without gravitational effect, the two gases will mix up with each other. You might have seen that whenever you burn something, like smoke is produced and that smoke get diffused into the atmosphere, it gets scattered, so it get intermixed with the other gases. Rate of diffusion is equal to volume the gas diffused upon time taken for diffusion. Volume the gas diffused upon time taken for diffusion. How much volume the gas is getting diffused per unit time? Understood? Yes or no? The volume upon time means cubic centimeter per second, or dm cube per second will be the unit of rate of diffusion. Rate of diffusion means how much volume the gas is getting diffused per unit time. So tell me, what is this question? Yeah. Yeah. Any idea? All of them. All of them. One atmosphere is equal to all of them. Right? We discussed all these units. Yes or no? Right. Now we discuss about the gas laws. Gas laws. First law I will be discussing about the Boyle's law. You can write here Boyle's law. So what we do is, if I keep the temperature constant and apply the pressure, the piston will come down and the pressure will increase. Yes or no? And the volume will decrease. If I decrease the volume, the pressure will increase. But I have kept the temperature constant. Yes or no? Yes, Aksham. No. Okay. Here I have a cylinder. Can you see that cylinder? Here I have gas particle. And what I'm doing is I'm applying the pressure. The volume will decrease and the pressure will increase. This is the Boyle's law, that is write down at constant temperature, volume of a given mass of a gas is inversely proportional to its pressure. Inversely proportional to its pressure. I hope you got it now, right? Yes or no? Right. It means what we can now say, volume is inversely proportional to pressure at constant temperature. So volume is equal to constant K upon P, or I can say PV is equal to some constant K. PV is equal to some constant K. Note it down. Right. So I can say P and V, these are inversely proportional. So this thing already I have given you. Yes or no? Right. So I can say P1 V1 is equal to P is equal to some constant. If I change the pressure, the volume will also change. The P2 V2 is also equal to constant K. So I can say P1 V1 is equal to P2 V2. We will be using this formula for the numerical purpose. Okay, note it down. Yes, Aksham. Okay. So I can say, wait. P versus V at a high pressure, I have low volume. But if I increase the pressure, the volume will decrease. Right? Or I can say if I increase the pressure, the volume will, if I decrease the pressure, the volume will go on increasing. Draw this graph. If I increase the volume, the pressure will decrease. Or I can say if I increase the pressure, the volume will keep on decreasing. More the pressure I apply, more the decrease in volume. At low temperature and at a high temperature, the graph will move up, right? So these graphs are being drawn at a constant temperature. Such type of graphs are called as the isotherms. Isotherm means the graph drawn at a constant temperature. Graphs drawn at constant temperature. The graph drawn between pressure and volume at a constant temperature is called as a isotherm. Isotherm means the graph drawn at a constant pressure. Okay. So if I draw at a V versus 1 upon P, V, then it will be straight line. When the pressure decreases, the 1 upon V value will go like this way, right? It means when the pressure will become 0, the volume will also 1 upon P value will become 0. Yes or no? So this is at low temperature and at high temperature. Okay, done. So I guess the P into V will remain constant at high temperature, at low temperature. PV is equal to constant. So the graph will be straight line. Yes or no? Right. So after this will continue next time. Right. Do you find any difficulty today? I had done a different topic actually. It was not difficult. Okay. So I'm ending the session now and I'll see you next week. I most probably on Sunday. Most probably it will be Sunday. This time was changed, but it will be next Saturday, our normal timing, right? You will be informed, right? Okay then. I'm ending session now. Goodbye for now.